All right, so you were supposed to write and graph the direct variation equation that has given the ordered pair as a solution. If you haven't done that yet, you better pause the video and do those now. But let's go ahead and do them together here. So let's do the graph first. I feel like the graph sometimes is a little bit easier on direct variation. So it's direct variation, so I know that it goes through the origin. So I know that I have 1 point right there. The other point is 3, negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's the other point, and that's my graph, kind of. Ooh, it's hard to draw lines on this thing. Okay. So there's my graph. Let's do my equation. Remember, my formula is y equals ax, no b, right? I'm going to find the a value by plugging in the numbers. My x is 3, my y is negative 9. Divide both sides by 3 gives me a equal to negative 3. Let's fix that. So therefore, my equation is y equals negative 3 times x. So my equation is here. My graph is here. Let's do part B. I'm going to do part B by doing the equation first. So I'm going to replace the y and the x in this y equals ax equation for equals a times negative 7. And then I'm going to divide both sides by negative 7, which gives me a equals negative 4/7. So my equation is y equals negative 4/7 x. We can graph that. This is a direct variation equation, so I know it goes through 0, 0. And my slope here is negative 4/7. So that tells me to go, it tells me to go down 4. Oops. 1, 2, 3, 4. And right 7. 1, 2, 3, 4, 5, 6, 7. Almost out of space. But I fixed it. I got it enough. And that's my graph. Right there. All right, if you're having any trouble with these ones, make sure you can leave a comment as a question or find me in class. But otherwise, let's move on to our next example, our last example. So let's do the same kind of thing, a direct variation equation this time, but let's do it in context now. So hailstones form when strong updrafts support ice particles high in the clouds, where water droplets freeze onto the particles. Okay, so we're talking about hailstones. Question: if a hailstone is 7.5 inches at 12 minutes, write an equation that represents the hailstone's diameter, assuming the diameter varies directly with the time the hailstone took form. So, keywords here. Varies directly, right? Remember, varies directly means we are going to see this form of an equation, y equals ax. Constant rate of change with a 0 for its starting point. So we know that we're going to form the equation this way. This says that diameter varies directly with the time the hailstone took form, meaning diameter varies directly with time. So I have the diameter of my hailstone equals the amount of time that has gone by times this constant of variation. So that's what I got to figure out. I got to find my A. Well, notice that they give us a diameter and they give us a time. So we're going to plug those numbers in. 0.75 equals A times 12. And since we have this equation now, I can simply solve that equation to find the constant of variation. And once I have that constant of variation, I can write out my equation here. So I'm going to divide both sides by 12. And I got 0.75 divided by 12. I'm going to calculator that thing. That's going to be A equals 0.0625. So my equation then is D equals 0.0625 T. And that is, that's my direct variation equation. Notice what this says. It says that every time 1 minute goes by, the diameter increases by 0.0625 inches. So 1 minute goes by and it goes up 0.0625 of an inch, which is a small amount, but you know, after over time, obviously, at 12 minutes it's 0.75, so it does get larger and larger. And honestly, once you got a hailstone that is an inch in diameter, I don't know if you can imagine a hailstone that has an inch in diameter that's like half the size of a golf ball. That's not the kind of thing you want to be out in. That is killer hailstone weather. That is death by hailstone. So it's probably good that it's not a extremely fast rate of increase here. Okay, so there's my equation. Part B says, using your equation from part A, predict the diameter of a hailstone after 20 minutes. So I'm going to use this equation, 0.0625 t, and then it says at 20 minutes, what's the diameter? So the diameter is what I'm looking for, and the time is what I'm going to replace. So we have 0.0625 times 20. 0.0625 times 20. I'm going to calculate that again. That's 1.25. And that's inches. Right? So again, 1.25 inch diameter hailstone. You are in the house so that you don't die. Okay? Because that's scary. That's scary stuff at that point. Okay? All right, anyway, that's everything I got for you today. This is the end of lesson 2.5. Thank you very much for watching, and you can head back to Canvas, grab your assignment. Thank you. Bye.